Today we start trigonometry, my friends. This is a big topic. This is a topic that could be studied on its own in a lot of depth, and it will be a part of pre-calc, and it'll be a part of calculus and calculus 2, and trigonometry will apply to all the rest of the math that you do in a little, in certain ways. So this idea in 13.2 of radians and degrees, this is what a lot of it's based on. This is called the unit circle, or a unit circle. It's called a unit circle because its radius is 1 unit. So if it's centered at the origin, this is 1 unit. Now it could be a mile, or it could be a inch, or a foot, or whatever, but it's 1, right? We kind of ignore the units, which is funny in a unit circle, but we don't really care how far it is, it's just 1. So it goes out to 1, to the right, to the left, up and down, 1 in all directions. Unit circle. Now, radians and degrees, these are just two different ways to determine, if we start here, how far around the circle have we progressed. So let's say you start there and you go to here. If I go from start to end, there are two ways to express that distance, or that much around the circle. Degree-wise, I could say I rotated around the edge of the circle this many degrees. And to me, that kind of is based at the origin. If I stand at the origin and look out the x-axis, and then I spin myself and look out there, that's how much I've spun. That's the degrees. Radians, on the other hand, is in terms of the distance that I have traveled around the outside edge. All right, those are just two ways to say it. So like let's say that this is a distance of 2 miles. And these numbers probably won't correspond. But if I don't tell you let's just say this is 50 degrees. If I say that I spun 50 degrees, that's one way to say I went from point A to point B. If I say I walked 2 miles around the outside edge, that's a way to say I went from point A to point B. So radians and degrees are two different ways to say the same thing. You started at a certain point and you went around the circle a certain amount, either of degrees or of distance in radians. All right, so radians is kind of the new part. Let's talk about degrees for a minute. Degrees, here's some of this ink. A full circle, as you know from your past experience, is 360 degrees. So if you spin all the way around from here, all the way around the circle, you've gone 360 degrees. If you go halfway the circle, you've gone 180 degrees, and so on and so forth. On this next page, here are some common degree measurements. I'm not sure why some of the letters or some of the numbers are hard to see, but these are our unit circle places that you're going to get very familiar with over the next couple weeks. And you can see the full circle all the way around is 360, so it starts at 0 here at 1, 0, and it's also 360, that's all the way around. And you can see some key points. You've got the 90, which is a fourth of the way around, the 180. This 210 should actually be right there, down to 270, and then you've got some in the middle. You can go, this is just 30 degrees. So, if this is 90, this is a third of that, and here's 2/3 of that, and so on. One important idea is this. You don't have to copy down these full circles, but you do need to copy some things, and here's one of them. Coterminal. This comes from co, which is same, terminal, ending. There are infinitely many ways to name a certain spot. So let's just focus on one spot. Let's say coterminal, they end in the same place. Let's focus on this spot right here, 330 degrees. 330 degrees One way to say that would be start here at our starting point, and we always rotate counterclockwise. So that right there is 330 degrees. So what are other ways you could get to that point? Well, let's, in different colors, show different ways. Here's a way. What if I started here and went that way? So if the full circle is 60, then that would be 30. So another way to say that would be negative 30 degrees, because this was clockwise, right? Positive is counterclockwise. If you go the other way, that's negative. So are there any other ways to get to that spot? A minute ago I told you there are infinitely many, so there's got to be something. How about this? What if I start, go all the way around once, and then go to 330? So another coterminal angle with 330 and negative 30 would be 360, a full revolution, plus 330 more. That's 690. So 690 is coterminal. Well, what about another one? Well, how about this? Start here, go negative all the way around, and then go 30 more. So I go negative 360, and then 30 more. That's negative 390, right? Right. So these are examples of 4 coterminal angles. They all end in the same spot. And add another trip around the circle to any of those, and you get the same thing. Okay? So that's coterminal. Reference angle. Another thing you need to write down. If you get a number of degrees like, I don't know, 1123, the reference angle is the shortest angle, the smallest angle between our location and the x-axis. Let's say smallest angle to x-axis. I'll show you what I mean by that. 1123 degrees. This is going to involve multiple spins around the circle, right? We've got 360, still spinning, 720, plus another 360 would be 1080. You hear that on snowboarding. They did a 1080, and we spun around 3 times. So if I go 1080 to get up to 1123, I believe that's 43 more degrees. So this angle right here, the angle, which we usually use theta to denote angle, is 1123. But after my 3 spins, this angle right here, which we call theta ref, as in theta reference, would be 43 degrees. So 1080, I'm just making sure, yeah, 43 degrees. That just gives you an idea of how close it is to the x-axis. We could also say that this is coterminal with 43 degrees, and that would give you an idea of where it's pointing. If I just say 1123, I don't really know where that's pointing. If it's pointing to the first, second, third quadrant, unless I go around and figure out the reference angle or the coterminal angle of 43, I'm not sure exactly where that is. All right, so now one more topic for this intro. Next to our unit circle with degree measurements, which is this one, we have a unit circle with radian measurements. These are going to be a little bit more awkward, but let's just look at a few, and I'll show you how to compare. First of all, 90 degrees is the same as pi over 2. 360 degrees is the same as 2 pi. So as far as radians go, once around the circle equals 2 pi. And that seems maybe like it shouldn't equal 2 pi. Get some space here. Let's talk about radians. The entire circle is 2 pi radians. Now, a radian is a unitless measure, which means if the, this is about, let's see, 2 pi is 3.14, so let's say that's about 6.3 radians. If the unit is 1 mile, the radius is 1 mile, then all the way around the outside edge is 6.3 miles. If the unit is, 1 foot, then all the way around the outside edge is about 6.3 feet. And this is not just some arbitrary, like why did they make it up that it's 2 pi? Well, they didn't make that up. The circumference of a circle equals 2 pi r. So 2 pi times 1 in a unit circle, circumference equals 2 pi. So we're talking about distance around the outside edge, and if the radius is 1, then that's got to be 2 pi. Every location around the outside edge, every distance that you travel, remember, in degrees, we're talking about how far have we rotated. In radians, it's similar, but we're talking about how far have we traveled around the outside edge. Every location can be named in two places, in two ways. 30 degrees, pi over 6, same thing. 300 degrees, 5 pi over 3. So for this section, we need to know how to convert between the two. All right? I'm just going to do a little unit conversion. And those spots in those circles above, those are going to be important spots that we have to memorize coming up shortly. But for just any old degree, if you want to change it to radians, take the degree and multiply it by 1, but we're going to be clever in the way we write that 1. All right? You've rationalized denominators by multiplying by the square root of 5 over the square root of 5. Same idea here. We're going to multiply, if we want to get rid of degrees and call it radians, by pi over 180. This is 1. It's just our clever way to choose 1 so that it changes the units for us. So if I have, let's see, 315 degrees, I don't want to change it to radians. I'm going to multiply it by pi over 180. The degrees and the degrees cancel, the units cancel, and I get 315 pi over 180. Then I need to simplify 315 over 180, and what do I get there? Let's see, 315 over 180. 315 over 180, that's 1.75, or, let's see, that is 7/4. So another way to say this would be 7 pi over 4. So, according to this, 315 degrees is the same as 7 pi over 4. So let's go look at our circles. 315 degrees, right here. Look at your radians, 7 pi over 4. So shortly you'll just know that. When I say 315, you'll know that that's the same. But for right now, we're sticking with the formula, so you can change any one. If you want to go the other way, you can probably guess what you multiply by. If you need to change radians to degrees, you're going to multiply by 180 over pi. 180 and pi are the same thing. That's why this is equal to 1, right? Look at your circles. 180 pi. Same spot on the circle. It's 1/2 of the way around the circle. So this number is equal to 1. So we don't change the value, we just change the units that it's given in. It's like changing inches to centimeters. You would multiply by 2.54 centimeters over 1 inch to convert those units. That's the majority of this section. We are easing our way into trigonometry. All right, so the things you should know. Degrees and radians are two different ways to say the same thing, and that thing is how far around the circle have you traveled? Either how many degrees have you spun, or how far have you traveled around the outside edge? And whatever the unit is for your unit circle, that's the unit that your distance would be around that outside edge. So a couple definitions. You should know coterminal means angles that end in the same spot. You should know a reference angle. I've got some extra marks here, but you get it. A reference angle is the closest distance, the closest number of degrees to the x-axis. So, it could be over here. Wherever you stop, go to the shortest distance in this. Get to the x-axis in the smallest amount of degrees you can. That's your reference angle. And finally, changing from one to the other. All right, multiply by pi over 180 or 180 over pi, depending on which way you need to go. So this is just the beginning. We got a lot of trig to discuss in the next couple months, and I am excited about it. I'll see you guys here, young out.